Hello and welcome to the Kubernetes podcast from Google. I'm your host, Kai-Hsun Fields.
And I'm Mofi Raman.
In this episode, our guest host and AI correspondent, Mofi Raman, interviews Richard Liaw and Kai-Hsun from Anyscale about Ray and KubeRay. Ray is an open-source unified compute framework that makes it easy to scale AI and Python workloads, while KubeRay integrates Ray's capabilities into Kubernetes clusters. But first, let's get to the news.
Litmus Chaos, featured on the last episode of this podcast, episode 234, has completed a third-party security audit conducted by 7A Security. The audit consisted of a white box security review paired with pen testing. The results include 16 findings with a security impact, 6 vulnerabilities, 10 hardening recommendations, 8 threads to the project defined with detailed attack scenarios and fix recommendations, and recommendations for future security hardening in Litmus Chaos. The audit report emphasizes that Litmus Chaos has well-implemented security efforts that reflect well on the function, build, and maintenance of the project.
Google Cloud announced that NVIDIA L4 GPUs are now available on Cloud Run in preview. Cloud Run is a serverless execution environment for containerized applications in Google Cloud. The release of GPUs on Cloud Run opens the door to many new use cases for Cloud Run developers, such as performing real-time inference with lightweight open models, serving custom fine-tuned GenAI models, and speeding up existing compute-intensive Cloud Run services.
A number of co-located CNCF-led events took place in Hong Kong between 21st and 23rd of August, including KubeCon, Cloud Native Con, Open Source Summit, and Open Source GenAI and ML Summit China 2024. That's 4 events in one. The event featured a number of excellent talks, including a keynote from Linus Torvalds.
The CNCF-hosted Colo schedule for KubeCon Cloud Native Con North America 2024 is live. The co-located events will take place before the main schedule of KubeCon on Monday and Tuesday, November 11th and 12th, 2024 in Salt Lake City, Utah.
Kubernetes 1.31 became available in the Google Kubernetes Engine Rapid channel on August 20th, just 1 week after its release. Information about the new features and deprecations in 1.31 on GKE can be found in the GKE release notes. And don't forget to check out our interview with the release lead to learn more about 1.31.
Red Hat announced the general availability of Red Hat OpenStack services on OpenShift. OpenShift is a container application platform designed for developers based on Kubernetes. OpenStack is an open-source platform which allows users to build and manage private or public clouds with their own pooled virtual resources and is designed for system administrators. OpenShift and OpenStack represent different approaches to the challenge of distributed computing. OpenStack is particularly popular in telecommunications use cases. This new offering provides a native way to run the virtual resource management tool OpenStack on top of the Kubernetes-based platform OpenShift.
Broadcom hosted the VMware Explore conference in Las Vegas from August 26th to 29th. Among the announcement at the event was the release of Tanzu Platform 10. Tanzu Platform 10 allows you to choose between Cloud Foundry and Kubernetes for your platform runtime, whether in public or private cloud environments. Among other new features, this change enables users to create more streamlined workflows for developers, especially those developing GenAI-powered applications.
The CNCF shared that since launching the Kubestronauts program at KubeCon EU 2024 in Paris, over 500 Kubestronauts have joined the program. Each of these 500-plus Kubestronauts have active certifications in all of the CNCF's Kubernetes certifications. That's the KCNA, the KCSA, the CKA, the CKAD, and the CKS. And I'm not going to spell those out for you right now. Make sure you go look them up. If you pass all 5 of these certifications and have them all active at once, you too can become a Kubestronaut. You can find links to more information about the program in the show notes.
The Dapper community will hold a virtual Dapper Day event on October 16th. Dapper stands for Distributed Application Runtime, a free open-source runtime system that helps developers build distributed application. The community will be celebrating 5 years of Dapper. The schedule for the event is now live.
And that's the news.
In this episode, we have Richard Liaw, who is a member of the product team at Anyscale. He was previously working on the Ray open source project, as well as one of the authors of the original Ray paper. Richard, welcome to the podcast.
Thanks. Happy to be here.
We also have Kai-Hsun, who is the maintainer of the KubeRay project. He's also a member of the Anyscale team. Welcome to the podcast, Kai-Hsun.
Yeah, hi everyone.
Richard, how did you get involved with the Ray project?
Back in 7-8 years ago, the project was being started at UC Berkeley, and this is a period of time where everyone was very excited about reinforcement learning, and there was no sort of simple system to build reinforcement learning applications at scale. So the Ray project came out of the work that Robert and Philip were doing on like distributed deep learning, distributed reinforcement learning. And I was an undergrad, sort of a starting graduate student at the time at the Berkeley RISE Lab. And I started building reinforcement learning applications on top of, and algorithms on top of Ray. This led to me and other graduate students working on RayTune, which was a distributed hyperparameter tuning project, and Ray RLib, which is a distributed reinforcement learning project. I spent a couple years doing that, and then when we started Anyscale in 2019, I also joined and eventually became the engineering manager on top of all distributed training solutions for Ray. And currently I've sort of moved on to work on other projects, including Ray data and LLM inference.
The same question to Kai-Hsun. How did you get involved with the Ray project?
Oh yeah, I think it is also a long story. I think at first it's that in my undergrad, I maintain an open source project named Apache Submarine. It is an ML platform that's built on the Hadoop ecosystem, on the Hadoop Yarn. And then we observe the transition from Hadoop Yarn to the Kubernetes, or also support on the Kubernetes. And then I also write an introductory paper, and then I found the open source project that is the Ray, and the cite the paper. And I found it is pretty interesting. So when I just go to the US, I just joined the Anyscale to work on the KubeRay, and then I work on the Ray core stuff. Yeah, and currently I've put more emphasis on the Ray core side, on the distributed training. Yeah.
So we already mentioned the word Ray a few times, but for our listeners who probably are not familiar, if you had to describe Ray in a few sentences, what is Ray?
I'm happy to take that. So Ray is a compute engine for scaling AI workloads, and it offers a set of libraries, including libraries for training, serving, data processing, all built within, using a Python front end and integrating very closely with the rest of the machine learning and AI ecosystem.
And in this space, I think Kai-Hsun also mentioned something about like Hadoop and Apache projects that exist in this space. And there are a bunch of other things like PyTorch, and there are things like Spark and Airflow, all these other things that exist. Around the same time in 2019, there was also a project called Kubeflow that was doing a bunch of things in the Kubernetes space. So while existing solutions that does similar things or does things that are in the same space as AI/ML workload, why Ray? Like, why was Ray created, and what problem was it solving in the time that was other solutions were not doing?
Got it. I think that this is a pretty good question. I think the first point is that I think before Ray, I think ML infrastructure is primarily in the microservice architecture after Kubernetes intro. For example, like maybe in the Kubeflow, I think you need to have like some system for the data processing and some operator for one for TensorFlow, one for PyTorch. I think it's recently combined into a one training operator, and you need to do some like use case serve or some stuff to do a serving. But I think it pretty makes sense for the control plane logic. But for computation side, I think people prefer to use a monolithic computation runtime. And Ray is pretty good at that because Ray is pretty versatile and general purpose. And ML workload is a very versatile workload, including like a data processing, training, tuning, and serving. And at each stage, you require a different kind of workload, a different kind of infrastructure requirement. For example, like the serving, you require like auto scaling and high availability. And for training, maybe you require like again scheduling. You also need to support different kind of accelerator and different kind of workload. Yeah, so I think it's changed very fast in the workload. And people want to use a single runtime for all the workload instead of use the microservice for different parts. Because if you use different part, you need to use like some YAML file, something to glue them together. But with Ray is that you can use a single Python file to cover end to end. Yeah, so I think that's why people like Ray, because it iterates much faster. You don't need to, and it can very flexible and much future proof. Yeah, I think this is from my perspective because I also maintain a project in the Apache Submarine. You can think it's also the microservice architecture stuff.
Richard, would you like to add anything in that one?
Yeah, I think the developer productivity aspect is pretty big. In particular, like a lot of data scientists and machine learning folks will use notebooks. And instead of writing machine learning pipelines in microservices and separate sort of containers, Ray allows you to do everything end to end in one sort of development environment. Especially with like a notebook, then you can sort of chain data processing with training, with batch inference, and sort of keep that all within the same sort of developer context. And that's very powerful and makes, building and iterating on machine learning pipelines much easier than before.
I think like from my experience of using Ray has been similar of experience of being able to write code that is in my local machine. That is like just Ray init sets up a Ray cluster on my local machine for me. And the code that from there going somewhere else on a Ray cluster on some sort of like a distributed system or Kubernetes seemed very intuitive. So I just wanted to kind of like speak to you guys to see if that was kind of like a design decision from the get-go, like make the experience of the people that are used to in the data science community, like having notebooks, not having to move too far from their Python environment. Like, was that something like a decision made early on, or was it something just organically happened?
So I think two parts. One is the part about developing locally and being able to scale into large scale context without having a lot of, without having a distributed systems PhD was one of the key design principles that we wanted to have when building Ray. Now, I think when it comes to the notebook sort of environment, that was something that was a natural artifact of us wanting to be able to, have the sort of developer experience and make sure that like we worked really well with the rest of like the Python ecosystem, the standard single process Python ecosystem. And so when it came to sort of seeing people start using Ray in notebooks and us actually giving tutorials, it became like, a very natural sort of evolution of how we would want the Ray experience to, evolve. Now, I think one thing to call out is in AnyScale, so AnyScale is like the managed Ray product. The developer experience that we tend to advocate for our users is focused on VS Code and sort of being able to develop scripts from scratch. And I think that's like one of the things that probably marks the difference between like a machine learning engineer versus like a data scientist. And that's kind of also an aspect of what we target, like people who are sort of working more on the machine learning side and building machine learning pipelines rather than data scientists doing large scale numerical computations.
Kind of going off from that, you mentioned like the machine learning engineers versus data scientists. And my work in the Kubernetes side of things, we actually deal with a lot of folks that are platform engineers. So from the Ray project point of view, if you had to define Ray's user on the other side, would you say the user base currently are mostly folks that are in the data science camp or machine learning engineer camp or platform engineering camp? Or do you see like a nice distribution between the three?
I think there's actually somewhat of this like undefined category that allows Ray to touch all of them at the same time. Like Ray is not only a machine learning engineering tool. It's not only like a platform engineering tool, right? It like with KubeRay, we make it really easy for these platform engineers to deploy Ray. With the Ray actual core APIs, like the machine learning engineer and the data scientists will use those. And same as when I mean Ray, like core APIs, I mean like the libraries and the Ray core primitives. And we see that like, with the libraries, especially some of the more higher level libraries like Ray Tune, like that's something that the data scientists will naturally have in their arsenal and at this point. So it is a tool for sort of a large swath of different people in common machine learning organizations at this point.
Richard, you just mentioned KubeRay, and we have one of the maintainers of KubeRay here, Kai-Hsun. So if you wanted to kind of add a little bit more understanding of what KubeRay is, why it exists, and why people should know more about KubeRay?
I think the first is that because I think Ray is a very powerful tool and Kubernetes is, I think Ray is a very powerful tool for the computation. And I think Kubernetes is the most powerful tool that's for like the orchestration and deployment. And I think KubeRay is Kubernetes operator to deploy Ray on the Kubernetes. And so that it can unlock the opportunity for user to integrate with Kubernetes ecosystem with Ray. Yeah, for example, like some schedulers, like the Cube, Volcano, Unicorn, and you can use like some observability tool, like a Prometheus, Grafana, FriendsBit, a lot of stuff, and some load balancer like the Nginx, like Istio. Yeah, so I think KubeRay is a Ray operator and unlock a possibility for users to, because in computation is not enough, you also need to have some deployment and a lot of stuff. And the Kubernetes ecosystem, I think, is a very good ecosystem to enable users to actually productionize the Ray.
So Ray have a number of these libraries, part of Ray core, as well as the Ray project itself. Is there any favorite that you want to talk to our audience more about?
Yeah, I think the Ray data project in particular is a really interesting sort of project that we're starting to focus more of our energy and resources around. It hasn't gotten a lot of public attention, but we've been doing a lot of work internally to make it better. And we've seen a lot of our customers and open source users sort of like really get excited by the abilities and capabilities that it brings. In particular, Ray data is sort of like a data processing engine in some sense, but it's largely focused towards AI workloads. And what that means is it's like being able to take big data and map it to your GPUs in a very effective, cost-efficient, performant, scalable way, right? So that means like having really good integration of like data pre-processing feature pre-processing, and then being able to ingest that into the GPU very efficiently. That's something that other systems like Dask wouldn't be able to support. And like the other side is batch inference, being able to handle sort of large models and scale out very, very quickly and handle all sorts of different data modalities, audio, text, image, videos, so on and so forth. And just to feed into those large neural networks that we have now, that's like somewhat of a unique capability.
Same question to Kai-Hsun. What is your favorite Ray library that exists?
I think research provides a very flexible way to do like the multiplexing, because I think in the production side, we see a lot of users that they need to use a lot of different model in a single graph. And I think Ray research provide a very easy way for that. And I think the second is that because as we said that it is a monolithic runtime, and we see some very useful benefit from it. For example, I think because in Array, a single scheduling unit is a test and actor, which is a function or a class, instead of the container. So some of our users that at first they use several microservices to serve the model, maybe one Golang microservice and send to a Python microservice and send to the other Golang microservice. And then when they use a Ray server to combine all of them together, because they can avoid a lot of time on the serialization and deserialization, and they can share the resource between the stage. So I think they reduce 50% of their cost. Yeah, I think this is the public blog from the Sensara. So I think this is a pretty cool use case for me.
I think a bit of a personal, not gripe, but a challenge for me is that a lot of the names in the Ray Serve and Ray job space gets kind of overlapping on the Kubernetes space, because Kubernetes have service and they have jobs. So there is a definition of Ray job in the KubeRay operator. There's also a Ray space job on the Ray definition. Like when folks go about like speaking and learning about these things, like what have you seen as to be the most challenging part of mapping all the Ray concepts in the world of Kubernetes?
Yeah, I think it is actually not easy to integrate around like a Ray on the Kubernetes, because at first I think Kubernetes is primarily designed for the microservice architecture. For example, I think in the best practice is that in each container only run one single process. But I think in the Ray is that we run multiple processes in a single container. each array test and each reactor is also a process. So we have a lot of challenge about that. For example, because we run multiple process, so it will be very hard to integrate with some login tool that's on the Kubernetes side. Yeah, and because I think the Kubernetes, a lot of tool is that reading a standard out and standard error, but Ray have a multiple process, so it need to write some logs into the file instead of the standard out and standard error. And I think the other side is maybe the auto scaling, because I think typically the auto scaler like the HPA or Carpenter, I think in the Kubernetes world, it assumes that maybe all the part in a single deployment or something that it is stateless. And you can use a resource utilization, like the CPU or memory utilization to decide to scale up or scale down a part because it is stateless. But in the race that is different, it splits a single application across multiple nodes. So you didn't know that is this part that is it which part of this application running on this node. So it is possible that if you use a physical resource utilization to determine to scale down this part, it may break the application. So Ray need to implement the autoscaler by ourselves. So I think one of the challenges that we need to make the Ray more friendly for the Kubernetes. I think we become better and better. Yeah, but still needs to have some help from the Kubernetes ecosystem and the community.
And this is a question, I think, for Richard, that the Ray project itself started about in 2019 as a research from universities. And then over the next few years, as the industry itself has evolved and changed, the Ray project also evolved and changed. About 5 years into the Ray project existing, for the next few years of Ray, what are the big challenges the Ray team and the project itself are thinking about?
So this is for the next, how many years you said?
Let's say the next 5. The first 5 is, we're in the first 5, and how about the next 5?
Yeah. I think machine learning is moving so quickly that it's just a constant reinvigoration of the project that needs to continue to happen. One big thing that Kai-Hsun is working on right now is this thing called accelerated DAGs, which allows us to program GPU clusters with any sort of accelerator and be able to write these sort of efficient distributed programs that take advantage of GPU interconnects and open up the space for different applications that leverage GPUs in special ways. For example, pipeline parallelism is something that the ecosystem and the machine learning community is starting to pick up and use more and more. But the abstractions for pipeline parallelism have sort of been quite limited, both on the training and the serving side. And so one of the things with Ray DAGs is Ray sort of accelerated DAGs is being able to compose and create these efficient and effective and fault-tolerant pipeline parallel training and inference pipelines very, very quickly. That's something that we've sort of needed to adapt and wasn't part of the original sort of story around Ray. I think the other sort of thing that we're also seeing is the rise of multiple accelerators, TPUs being one, sort of the AMD being another, and Trainium and Inferentia being sort of another. And for Ray to continue to be relevant as the default substrate for distributed computing, that's obviously something that we have to be aware of and be able to sort of schedule over, be able to do memory management over, so on and so forth. So that's part of sort of the vision that we have and allowing us to have a substrate for managing sort of resources over for AI workloads.
Okay, I think that's a really great answer. The next question to the both of you is, what is one or two things about Ray that you want people to know, but have been finding that in the community people have misconception about? And this is the place you can just set the record straight and let people know this is one thing they should know about Ray if they had to.
You say that I think users should know?
Yeah, and it's something the people you find in the community are either not understanding or have misconception about anything about Ray that it would be good for people to understand differently. If there is nothing, everybody's getting Ray exactly as folks intended. That's fantastic. But oftentimes, people either think it's too difficult, or it is you need a huge GPU cluster to run it, or it's hard to learn, or anything you think in the community people are finding like you are hearing over and over again about something, but you think that's a misconception?
God.
Yeah, the only thing I would probably say is just like, I think more people should be aware of Ray data. I think there's a lot of people who are doing like, batch inference or trying to force their like image processing pipelines to run with some really weird, MPI setup or whatever. And Ray data will probably make your life like 100 times easier. But there hasn't been a lot of like, public discourse around it. And I think that's something that I'd be excited to fix.
Yeah, hopefully this will get the conversation going and people are going to learn more about Ray data. I have very limited experience of Ray data, but I think from my experience, it is actually made a lot of sense. Like the functionality that is built into Ray data just made a lot of sense compared to my knowledge in like pandas and NumPy. Like bringing some of those stuff over to Ray data have been quite a breeze. So I'm a fan personally.
Yeah. Yeah. So you're one of these guys. You got to try out Ray data again.
And I think the last question I wanted to ask to both of you is that in your work over the last few years in the community and with people and possibly customers, is there a time where you've seen folks use Ray in a way where either was surprising or sometimes even eye-opening for the Ray team to see like people in the community using the project or the libraries in some way that the original thought wasn't there? Like you didn't think people could use it this way?
Yeah, I'm happy to give a response here, and Kai-Hsun, you can add on as well. There's this one guy on Twitter, I forget what his name was, but he like connected like a ton of MacBook Pros together, or like MacBooks, like laptops together to create like a Ray cluster. And he was like, I forget exactly what he was doing. I think maybe training a model, but that was like kind of mind blowing, and it blew up on Twitter as well. The odd thing, I mean, obviously Ray is a distributed framework, but it's usually distributed for like cloud data center servers, right? And this guy was like connecting his laptop and whatever. So that was really cool.
Yeah, I think maybe for me is that I think maybe one of the things that I found is that some people that use the container in container. Yeah, people want to launch a container inside the Kubernetes pod. For example, if you serve some model and they don't want to back all the stuff in a single image, and then they want to. So if they want to launch this kind of model, they launch a container in the container and with some additional image. Yeah, so they don't need to back everything that's into a single image. And yeah, I am very confusing about that. But to be honest, some people use that. And it seems work well.
Yeah, I think I was speaking to like a few months ago, it was the 10-year anniversary of Kubernetes as the project. And I had a chance to meet with a bunch of the original contributors and the maintainers in that space. And I asked this question to a few people, like, do you think, like, can you think of a time like or an example of people using Kubernetes in a way you initially did not think? And the answer I got overwhelmingly is like 90% of the things people are doing on Kubernetes today, they did not think was like an initial use case for Kubernetes. Kubernetes was initially created for like stateless applications, like web applications to scale massively on the cloud. But people found all sorts of interesting ways to use Kubernetes in many ways. And over time, I think the project itself like caught up with stateful set stuff and storage, and now accelerators to GPUs and TPUs and a bunch of other things. Last KubeCon, there was a talk on the Kubernetes schedule, like KubeCon schedule, about using FPGAs as a operating unit on Kubernetes as well. So people are finding all sorts of cool, interesting ways to use these things. And it's always exciting for me to like hear these stories like the one Richard mentioned about like using a MacBook Pro Ray cluster. Richard, you mentioned accelerated DAG. Can one of you kind of like explain a little bit more what it is? It sounds interesting, but I don't think our listeners are going to be completely clear of what that does.
I think maybe I can tackle that part because I'm working on this project, accelerated DAG. I think accelerated DAG is that because I think a Ray is that you can say currently the Ray is a resource architecture. And then accelerated DAG is that first is that reduce the system overhead that's from Ray. And then the second is that we want to do more about the accelerated-centric computation, like use some protocol like a Nickel and maybe RDMA in the future to accelerate the system overhead. And we are talking on two kinds of the workload. The first one is the large-scale inference. And the second one is on the large-scale training. And I am primarily focusing on the large-scale training. And I think Azure Deck provides a very simple API for you to, for example, define your a pipeline person. And in my experience is that I think there is a very popular strategy of pipeline person and the Liaw bubble pipeline person. It's from a researcher team in Singapore. And you can see their open source repository. They fork Megatron and then add some patch on it to implement the Liaw bubble pipeline person. And you can read the patch. I think it's still, maybe it is a short patch, but you require a lot of knowledge from the Megatron to implement this patch. But with the Ray Azure Deck, you just need to have maybe 100 lines of code in a single Python script and import Ray, and you can implement it. You don't need to fork Megatron. So I think Megatron is pretty powerful, do a lot of application, but Ray is Azure Deck provides a very flexible way for you to define your distributed strategy.
Okay, so I'm going to actually ping you later for the links that you mentioned. I think they're going to be really good to have in the show notes for people to have access to those. Richard, Kai-Hsun, thank you so much for spending this half an hour with me, answering a lot of my questions about Ray. Hopefully, people will get some interesting insight into the Ray and KubeRay project. Before we finish, anything you would like to end on, either anything new things that people should be excited about that are coming from either the Ray project or the KubeRay project, and we can finish on a hopeful future note.
Yeah, I think a KubeRay community, we recently focusing on several perspectives. I think the first one is for the long running job, and we define some how does it handle if it fails, and figure out the best practice for the how to do a checkpointing. Yeah, and we collaborate very closely with the Google Kubernetes team. Yeah, and the other side is that we are also focusing on the support heterogeneous computing resource. For example, we also collaborate with the Google Kubernetes team on to support the TPU and the multi-host TPU, and we support the auto scaling for the multi-host TPU. And I think that this is maybe currently the only solution that's in the open source world to support a different kind of resource and support a multi-host auto scaling. And the third one is that we also currently build some ecosystem for usability and security. I think we currently build some the authentication solution that's on the KubeRay side. And we also build some some easy to use the a kubectl plugin for users. Yeah, and we are also figuring some upgrade mechanism for the serving recently. Yeah, so I think there are a lot of stuff still on the roadmap. Yeah, so I think it's pretty exciting, and the community becomes much and much popular.
On that exciting note, thank you so much, Richard and Kai-Hsun, for joining in this episode of Kubernetespodcast. And the social accounts for both Kai-Hsun and Richard will be in the show notes, so people can go follow and ask probably more questions about Ray and KubeRay. Thank you so much.
Thank you. Bye-bye.
Thank you very much, Mofi, for that interview with Richard and Kai-Hsun from Anyscale about Ray. I've been really looking forward to Ray, and I'm excited about what I learned. But first off, welcome back to the show, Mofi.
Yay, I made it back again.
Woo! Mofi, in his day-to-day work, when we do, that kind of stuff, is the primary person on our team focused on AI stuff. So he has been kind of deeper in Ray and AI use cases on Kubernetes than anyone else on our team. So I was excited to have him do this interview. Since you have more context in this area, you're able to kind of dive a little bit deeper into it. I know as I was listening through the episode, I heard you asking some questions about things that you've seen, and so I really appreciated that perspective.
Yeah, I think from our point of view, Ray is one of the very fundamental building blocks that we are thinking that we, along with other customers and people in this space, would be using for building out their ML platform. So in our work that we're working with customers as well as folks from the community, when we're thinking about an ML platform, it is a fairly difficult thing to describe for people because ML platform means very different things to different people. But the fundamental things that people need from not just ML platform, like any developer platform, it's It's things like multi-tenancy, it's things like getting resources when you need them, and some version of self-servicing. And in many cases, a lot of the cloud provider system like GCP and things like other cloud providers, you have some system where people can do self-servicing, but for most organizations, that permission system is probably too open. So they end up building some level of guardrail around it to control or limit the amount of knowledge needed to do the day-to-day task for the developers and data scientists and machine learning engineers. So people build out different level of abstraction for their folks to have access to resources in some ways. And when you're doing all of that, I think having some sort of way to define your workload in a way that doesn't need to change across a lot of this boundary that you cross, Ray actually becomes really useful in that space. You can define your workload in Ray. You could run that workload from your local machine, as well as run that in a distributed manner in a massive scale. I think that's one of the things I also talked to Richard and Kai-Hsun about, is that the model of Ray seems to fit very nicely in the world of, I want to do something locally, do some experimentation, but then take it out to a distributed computer and scale it out to basically as big as I need to.
So I've been trying to learn about Ray for a while. It's been on my list for actual work stuff that I need to do for some time. And I feel like this conversation has finally got me kind of near a baseline, at least. So I like the way that you laid that out as kind of the primary use case that at least we're really focused on in terms of how Ray relates to Kubernetes is all about enabling this kind of workflow where engineers, data scientists can create their AI stuff with Ray, and then you can run Ray on Kubernetes, and so you can productionize it easily. So you've got kind of this path from your local machine to production. I think that makes a lot of sense.
Yeah, it's also a really interesting conversation with someone like Richard, who have been with the project from a really early stage of the project as well, where Ray was initially almost like a library for doing some data science work. I think Ray RL-lib and Ray Tune was the first two component of Ray. So one of the things that is interesting about Ray as well is that it's a end-to-end things that are all part of Ray. So they have Ray Data, Ray Core, Ray Serve, Ray Tune. Ray Cluster is the also concept of building out the cluster. We spoke about a couple of other projects in this space, like Airflow is something, Qflow exists in this space, Ray Spark also exists in this space. And one of the key challenges a lot of folks have with these things is that when you are building things, the way you locally test things, and you have to convert those things to something else, turn them into jobs or containers to run them on Qflow and other things. With Ray, you could kind of have this end-to-end flow all part of under the Ray umbrella. In terms of making sense of your problem and understanding the problem space, once you have done the initial investment of going all in on Ray, I think you have a really nice way to wrap and map all your problems or most of your data science problems in the world of Ray. So once you have done the initial investment, it kind of becomes okay, it's a gradual progress from that point on.
And I didn't know you all, I guess Richard mentioned in his intro that Ray came from UC Berkeley. It was a university project that kind of developed into a whole product.
I think Richard at the time was, doing his research and a postgrad research there. And he was working on distributed systems. And when you're talking about distributed systems, doing it manually or doing it in more complicated ways, the Ray came from, and this is what I love about projects that come from trying to solve a very specific use case, and then they find out this is actually maps to a lot of other use cases like this.
Surprise.
I mean, one of the biggest example of that probably is Kubernetes, right? Kubernetes initially was trying to solve the problem of running stateless distributed applications on cloud commodity hardware. At Google, with Borg, the engineers were doing this, and they wanted to figure out how do I make sure this just works across any kind of hardware. But now Kubernetes, kind of an anecdotal story, in the 10-year celebration time, a few months ago, in the last KubeCon, I ran into Tim Hawkins, and I was asking, the thing people are using Kubernetes for. Did any of you initially thought people would be using any of this for?
Yeah.
They're like 90% of the, and Tim told me 90% of the things people are doing with Kubernetes now were not like initially designed for, right? Like AI workload, running databases, right? Stateful workloads. These are not the initial subset of things Kubernetes was designed to do, but Kubernetes was built with a strong sense of we want to solve this problem. And people found out that other problems also map pretty nicely in a distributed system like this. So Ray has very different, but also kind of similar story to that, where they're trying to solve a very specific use case for their distributed workloads. But turns out a lot of machine learning and AI ML workload kind of mapped to similar paradigm.
Which is awesome. The generalization of the usage of distributed systems. Distributed systems is just such a common problem of I have a lot of hardware and I want to run stuff on it. So it makes a lot of sense that these things get kind of generalized out. And something with Ray that I'm kind of trying to wrap my head around. So Ray has all of these different components, like you were mentioning, Ray data, Ray core, Ray accelerated DAG. And so it has all these different components. I know that there's an API component to it. It's not a language of itself. So is it kind of like an open source API standard with all of these modular components in different areas, or?
So most of them are just Python libraries. So if you are using Ray
right?
data, so you would be closer to something like NumPy or Pandas that have similar functionality. So, and this is also anecdotal. I was speaking to someone, and also my personal little bit of tinkering that I've done with Ray data. They have they have taken a lot of inspiration and learning from other existing libraries in the space and tried to simplify all the things people found as challenging in those things, like understanding and mapping machine learning and data science concepts in code in some way. So if you're coming from the world of Pandas or Scikit or NumPy and trying to map your knowledge into the world of Ray and Ray data, I think you'd have a pretty nice time. I think most of the things work as you'd expect it to work for the most part. So that's another reason people are I think a lot of folks do like Ray libraries, because their existing knowledge in the data science concepts almost always kind of map fairly easily onto the world of Ray.
So if it's mainly a set of Python libraries, essentially, what benefit do you get from running KubeRay, from the operator on Kubernetes?
So Ray has basically at this point, initially when Ray started, it was mostly libraries, but now Ray has evolved to the point of it is the library, but also the execution engine underneath. So the things you're running on Kubernetes, so in terms of the workload that runs within the Ray serve and Ray job, which is the construct they have for running the workload itself, that doesn't necessarily need you to use any of the Ray core libraries. You could continue using your NumPy code. You could continue using your Scikit, Learn, Pandas code. The way the Ray infrastructure layer works, you add some annotations, and that lets the Ray engine understand that this thing has to get spread across, remotely spread across a bunch of computers. So if you look through the Ray documentation, you're going to see a bunch of these annotations like Ray task or Ray remote and things of that nature. So you can define any Python function as a Ray actor. And this actor can be then spread across, you can distribute it across any number of Ray remote runtime that exist. So you can actually almost think Ray as broken down into two major parts. One is the library part itself, where all this data science and machine learning code and library exist. The other one, the infrastructure layer. When Ray first started, it was mostly in the library side. They did not really think about the infrastructure. But as Ray grew, the need for having more of an infrastructure solution became more and more apparent. So the KubeRay part of it is the operator that installs the Ray job, Ray service, and Ray cluster as a construct into Kubernetes. And on top of that, it could run any type of Python code. But Ray also comes with a bunch of this existing Ray data, Ray tune, and Ray reinforcement learning libraries, part of the Ray core itself.
And we've talked on the show before about some of the limitations of kind of similar concepts in Kubernetes. You mentioned during the interview that there are a number of words that are kind of shared between Ray and Kubernetes, and that could get a little bit confusing, like the concept of Ray jobs and the tasks and things like that.
So it's not just Ray and Kubernetes. In general, there is concept of like the job itself is such a ubiquitous term. Like it exists in the world of HPC and it exists in the world of just in general. So when you say something is a job, it can mean so many different things. So like one funny example, we actually published a video, we can add it to the show notes, is that in Kubernetes, there is job. When you have a Ray job in Kubernetes, it's the Ray's job without a space. That is the Kubernetes resource definition of Ray job. And then inside Ray, they have a concept of a job, which is spelled Ray space job, which means like execution of a Ray bit of Ray code. So when you read it out loud, Ray job versus Ray job, it is just becomes very complicated to think about. But the easiest way to think about it is a Ray job, that is the Kubernetes one. It is the Ray job, the Ray code, plus a submitter that submits the code on your behalf. Together, they become Ray job without the space. As I'm saying it for the third time, I feel like I am getting confused what I'm saying, but like, so one of them, without the space, it's the Kubernetes resource definition, CRD, that defines the Ray code plus something that submits the code on your behalf to a Ray cluster. Versus a Ray cluster is kind of like a bunch of resource to get bundled together, which will be used to run your code, if that makes sense.
This is a challenge with abstractions and layers of abstraction, is you're taking a lot of the same concepts and abstracting them at different levels. And so they kind of have similar names. That makes sense, though. At least that would happen. Whether or not I can wrap my head around using the right ones at the right times, we will see. Awesome. So another thing that I really liked about your interview is that especially Kai-Hsun and you both mentioned a lot of different tools kind of in the same spaces all at the same time. So there was a section, for example, where Kai-Hsun mentioned different schedulers, so like Q and Volcano and Apache Unicorn and observability tools and load balancers. And I liked that kind of gave this view of this isn't something that's going to exist in a vacuum, obviously. It's part of a distributed system, and so it's going to require all of these other components. You'll also mention about the benefits of being tied into Kubernetes. One of the benefits is that you get access to the whole Kubernetes ecosystem because there's already so much stuff there that you can kind of tie together with Kubernetes to build your whole platform that you really need. So Ray is one component of this. It's doing the custom resource definition, and it's also a tool for developers, I guess.
Yeah, so if you actually were to open up the Ray docs and kind of go to the overview, they have actually a pretty nice picture that defines the relationship between all the parts of Ray fairly nicely. So at the very top layer, which is all the Ray AI libraries, which is the Ray Data, Ray Train, Ray Tune, Ray Serve, Ray RLlib, all of them exist as a library. Those are interchangeable. You could use the Ray versions of those libraries, or you can find any other Python code that would do the work. Underneath is the Ray core, which is the actors, your remotes, all the ways you can basically define how Ray would distribute the workload for you. All of them are usually defined via some sort of annotations in your Python code. So most of Ray code, if you just have those annotations, your code would just work as a Python function. But the moment you start running them in Ray, Ray would understand the annotations and run the code a little bit differently, right? So that's kind of a very elevator pitch of how Ray kind of does the things. And all of the Ray core stuff then eventually runs on some sort of infrastructure. So that could be Anyscale's own service. It could be Kubernetes. It could be running on a VM. It could be on your own data center on bare metal. But Ray core is the code that is running on some sort of place where compute can run on. Now, one of the things in this is missing is that Ray itself does not necessarily have a lot of consideration or solutions built in for things like observability, logging solutions, or things like scheduling out to Kubernetes. And which I think is a good thing, because if Ray were to solve all this, it'll be a very locked in system. But now that they are falling back onto things like Q, Unicorn, and Volcano, makes Ray a lot more composable and makes sure that people can build out. It's a more of a composability aspect of Ray, which I really like. Another project in this space that solves a bunch of this AI and ML related problems that started a while ago too, it's Kubeflow, and it comes with a lot of the pieces bundled in, and you have to kind of have all these glues connected to other things. So Kubeflow comes more like a framework where all the moving pieces are all under Kubeflow. And on the other hand, Ray's approach is more like Ray is a piece that you plug into your system and collect the metrics that you want, collect the logs that you want. And the challenge with that then is you have to maintain your own metric system, own log system, and also security. Ray does not have a concept of authentication, OAuth, or like SSO, all this other stuff in the Ray cluster. You have to kind of wrap it yourself using your systems. So it's a bit more work, but makes it more composable.
Awesome. So I think I've got a good baseline now, hopefully, for understanding Ray a little bit better. I hope to dive into it more in the next week because I need to do some work on that. So I hope all of you out there enjoyed learning about Ray, and we'll check it out. Any last words that you want to say about Ray, Mofi? I feel like I'm doing like a second interview here because I wanted to learn from you about this.
Yeah, so there are like few big aspects to Ray, which is Ray is whatever the person using Ray, like Ray to them is different. Like if you're someone who is very deep into the AI workloads itself, you're probably like a very deep into the Ray libraries versus me personally, I'm probably more interested in the Ray core and distributed aspect of it. So even when two people are talking about Ray, oftentimes we're not talking about the exact same thing because Ray is like have multifacets of doing different solutions. But when you're talking about like building an ML platform, which we are currently, a lot of folks are thinking about, I think Ray becomes one of the pieces, the Ray core part of it becomes one of the pieces that you can use to have a way to like distribute your job across. And KubeRay in GK recently also announced the Ray add-on that automatically installs KubeRay on your cluster. And so with all of this, it becomes like a little bit easier to get from Kubernetes to Ray. That glue point, the connection point becomes a little bit easier.
So you mentioned like we've talked a lot here about kind of the pathway from local development to Kubernetes clusters. And also kind of mentioned that there's several different personas here. So like for those running Kubernetes clusters, if you're serving data scientists who might be using Ray to do data science things, then you might want to consider looking into how to get KubeRay on your clusters and see if your data scientists can benefit from that. And then from the other side, if you are a data scientist or some developer who is working on AI workloads, you might look into the Ray libraries to see if they're useful. Does that kind of cover, do you think, some of the primary personas?
It definitely does. I think, yeah, like you have basically about three main ones, right? You have the Ray cluster one, which probably we are more closer to as GK developer advocates. And then you have the machine learning engineers, data scientists that are doing their work. And in the middle, the glue is you take your Python functions and convert them into like distributed applications, and then they get to run. So you have main parts to it. And Ray makes it fairly easy with just like simple annotations that you can just put. So oftentimes the default decision that Ray takes are almost always fairly optimized for you. So you don't have to do too much work figuring out the right tuning of the distributedness of your application.
Excellent. And very last thing before we stop for this episode, Ray Summit is coming up. So there's going to be an event held in San Francisco focused on Ray.
Yeah, I think it's a really growing project with a lot of cool things coming up. In our chat, Kai-Hsun and both Richard and Kai-Hsun mentioned new things that are in the roadmap for Ray, both for KubeRay side of things and the Ray libraries. And I'm excited to see where the project goes. It's about 5 years-ish old, and it's only growing.
So if you're in the San Francisco area and want to learn more about Ray, you might consider checking out Ray Summit, which is at the very end of September, beginning of October, like September 28th to October 2nd or something like that. We'll make sure to have the dates and the links in the show notes. Thank you so much for that interview, Mofi. I'm really glad that I now know something about Ray.
Thanks for having me. That brings us to the end of another episode. If you enjoyed this show, please help us spread the word and tell a friend. If you have any feedback for us, you can find us on social media at KuberneteSpod or reach us by email at kubernetespodcast@google.com. You can also check out the website at kubernetespodcast.com, where you will find transcripts and show notes, and links to subscribe. Please consider rating us in your podcast player so we can help more people find and enjoy the show. Thanks for listening, and we'll see you next time.